Recall that at the end of part one of this experiment, we were left with a 250 milliliter beaker with some silver metal inside of it and a 150 milliliter beaker with some copper nitrate inside of it. For part two of the experiment, we are going to be working with the silver metal. And the first thing we're going to do is recycle this silver metal back into silver nitrate. To do that, we are going to complete this chemical reaction right here. We're going to react the silver with concentrated nitric acid. That's going to get us our silver nitrate back. It's also going to produce some nitrogen dioxide gas and some water. You can see that we need to balance this equation. I have given you the fact that there are 2 moles of HNO3 in this balanced chemical equation. So usually I would say leave hydrogens and oxygens till last, but since I've given you a number, a coefficient in this balanced chemical equation, we should start there. So if we have 2 hydrogens on the reactant side, we have to have 2 hydrogens on the product side. And you can see that we already do. So that means this coefficient here in front of the water has to be a 1. Let's go back and look at the nitrogens now. So the fact that I put a 2 here in front of nitric acid means we have 2 nitrogens on the reactant side. So on the product side, we need 2 nitrogens, and you got to be observant here. Both silver nitrate and nitrogen dioxide have 1 nitrogen in them apiece. So that means we have 2 nitrogens already. The coefficients in front of both silver nitrate and nitrogen dioxide, they must be 1. Let's look at the oxygens next. On the reactant side, you can see we have 6 oxygen atoms on the reactant side, which means we need 6 oxygen atoms on the product side. Look carefully. We have 3 from silver nitrate, we have 2 from nitrogen dioxide, and we have 1 from water. So we already have 6 oxygen atoms. The last thing we need to balance is silver. Since we put a 1 in front of the silver nitrate, there must be a 1 in front of this silver on the reactant side. And now we have a balanced chemical equation. Let's go ahead and observe the reaction. It needs proper ventilation because nitrogen dioxide is a toxic gas. So you will see that I completed this reaction outside. So here we go. I have gloves on because the nitric acid that I'm using is also pretty nasty stuff. You should have seen that orange gas that was given off. That is the toxic nitrogen dioxide gas. It's going to continue to be given off here as I swirl the beaker. That gas, before catalytic converters, was part of car exhaust and also the cause of the orange haze you'd see over big cities such as Los Angeles when you were flying into them. Now we're going to apply heat to this reaction for 2 reasons. First of all, it speeds up the reaction and makes sure all the silver metal reacts with the concentrated nitric acid. The second reason is to evaporate off all of the water and leftover nitric acid so that all that we have left is the silver nitrate in the solid form. As we get close to evaporating off all of the water, you'll notice that there is a blue tint to the solution. That is still from some leftover copper impurities from part 1 of the lab. At this time, you need to pause the video and complete page 7 of the lab. This picture should help you. On the left, you have the pure silver nitrate that I started with at the very beginning of part 1 of the lab. In the middle is the recycled silver nitrate that we just produced with that chemical reaction involving nitric acid. And on the right, we still have the copper nitrate from part 1 that we are yet to use again. We have our goggles and our 2 beakers. So let's mass the 250 milliliter beaker with the recycled silver nitrate. Record this mass in the data table on the bottom of page 6. This is the mass of the 250 milliliter beaker and recycled AgNO3. Now we're going to add 15 milliliters of distilled water and stir to dissolve the recycled silver nitrate. Be sure to address why not all of the silver nitrate may dissolve under step 2 of your lab. Now we are going to clean out the 150 milliliter beaker containing the copper nitrate. We no longer need the copper nitrate, so we're going to rinse out the beaker and dry it really well with a paper towel. Now we're going to mass the 150 milliliter beaker and record this mass in the data table at the bottom of page 6 as the mass of the 150 milliliter beaker empty. Keep the beaker on the balance, hit the 0 button, and then add anywhere between 2.47 and 2.53 grams of sodium chloride. Record the amount that you added in the data table at the bottom of page 6, where it says mass of NaCl. Now add 15 milliliters of distilled water to the sodium chloride and stir it up to dissolve all of the salt. When you do this, record the temperature using the temperature probe. Make sure to record the final temperature in the data table at the bottom of page 6, where it says temperature of NaCl in 150 milliliter beaker. While stirring the silver nitrate in the 250 milliliter beaker, slowly add the NaCl solution from the 150 milliliter beaker. Be sure to make observations and interpretations for this step in your lab. We're going to make sure we get all of the NaCl solution out of the beaker by rinsing the beaker with a few squirts of distilled water. Identify the formula of the new solid you just made. Make sure to record this formula under step 6 in the lab. You also need to record the temperature of this mixture in the data table at the bottom of page 6. Record this temperature where it says temperature of mixture in 250 milliliter beaker. Now heat the new solid you just made for a few minutes on the hot plate. While we are heating that solution, we can prepare for gravity filtration. Get the mass of a piece of filter paper using the balance that reads to the 10,000ths place. Record this mass in the data table at the bottom of page 6 where it says mass of filter paper. Now fold this piece of filter paper so that you can use it for gravity filtration. Taco. Pizza. Wet the piece of filter paper so that it holds its shape inside the funnel, and then position your 150 milliliter beaker underneath the funnel. After allowing the solid to cool, we can now filter the solid from the liquid inside the 250 milliliter beaker. We're going to swirl and pour, swirl and pour, swirl and pour to get all of the contents from the 250 milliliter beaker into the funnel. It is very important that we get all of the solid out of this beaker. So we're going to do a couple rinsings with distilled water and scrape all the solid out of the beaker that we can with our plastic spatula. After gravity has assisted all of the liquid through the funnel, our new solid, AgCl, will look like this. Remove the filter paper containing the solid from the funnel, place it in the 250 milliliter beaker, and then that needs to go into the oven to dry the filter paper and the solid. The beaker containing the liquid that went through the filter will go under the hot plate. We will evaporate off all of the water from the solution and we'll be left with another solid that is the second product of our reaction. Here is that second product, sodium nitrate, after all of the water has been evaporated. The next day, we can take our beaker out of the oven. The filter paper and solid should now be dry, and we can obtain the mass of both the sodium nitrate and the silver chloride. Record this mass in the data table at the bottom of page 6 as the mass of the 150 milliliter beaker plus NaNO3. Record this mass in the data table at the bottom of page 6 as the mass of the 250 milliliter beaker and filter paper and AgCl. At the end of part 2 of the lab, your data table should look like this. Use the data to determine the mass of the AgNO3, the mass of the AgCl, and the mass of the NaNO3. Use the data from the tables on page 6 to answer the questions on the last page of the lab. This picture of the products from part 2 of the lab may also be helpful for answering the questions. Good luck.